Article 680.8d of the National Electrical Code addresses open runs and states that direct burial cable, specifically UF cable, is permitted for branch circuits as open runs where supported on messenger wires or other approved means. However, it also states that direct burial cable (OFF) shall not be permitted for branch circuits as open runs within 10 feet of the ground or other accessible surfaces. Article 680.10b2 discusses service entrance conductors. It allows direct burial cable (OFF) for use as service entrance conductors when all conditions are met, but it is not permitted for use as service entrance conductors for commercial or industrial buildings. Based on these code sections, direct burial cable (OFF) is not permitted for branch circuits as open runs within 10 feet of the ground in commercial settings. This restriction includes lighting installations for helicopter pads. Therefore, the determination to require conduit and wire for the helicopter pad lighting is correct according to the National Electrical Code. Let's delve deeper into the reasoning behind these regulations. The National Electrical Code (ONEC) aims to ensure electrical safety in buildings and other structures. It provides guidelines and standards for electrical installations, minimizing the risk of fire and electrical hazards. The NEC is updated regularly to reflect advancements in technology and evolving safety concerns. UF cable, which stands for underground feeder cable, is a type of electrical cable designed for direct burial applications. It is commonly used for residential outdoor lighting, landscape lighting, and other similar applications. However, the NEC imposes certain restrictions on its use, particularly in commercial and industrial settings. The restriction on UF cable within 10 feet of the ground stems from concerns about physical damage and accessibility. In commercial and industrial environments, there is a higher likelihood of equipment being moved, vehicles being operated, and general foot traffic. These activities increase the risk of the cable being accidentally struck, cut, or otherwise damaged. If the cable is damaged, it could create a shock hazard or lead to a short circuit, posing a significant safety risk. The requirement for conduit and wire provides a greater degree of protection for the electrical conductors. Conduit is a rigid or flexible tube used to enclose and protect electrical wiring. It shields the conductors from physical damage, moisture, and other environmental factors. By encasing the wires in conduit, the risk of damage from external forces is significantly reduced. Furthermore, conduit systems typically include grounding conductors, which provide a path for fault current to flow back to the source in the event of a short circuit. This helps to trip the circuit breaker and de-energize the circuit, minimizing the risk of electrical shock. The prohibition on using UF cable as service entrance conductors for commercial and industrial buildings is based on similar safety considerations. Service entrance conductors carry the main electrical supply from the utility company to the building's electrical panel. They are typically larger in size and carry a higher voltage than branch circuit conductors. Because of the critical role they play in the electrical system, service entrance conductors require a high level of protection. Conduit provides a more robust and reliable method of protecting service entrance conductors compared to direct burial UF cable. It offers greater resistance to physical damage, moisture, and other environmental factors. Additionally, conduit systems allow for easier access and maintenance of the service entrance conductors. In the event of a problem, the conductors can be readily inspected, repaired, or replaced without having to dig up the entire cable. The NEC recognizes that direct burial UF cable can be used safely in certain applications such as residential outdoor lighting. However, in commercial and industrial settings, where the risks are greater, conduit and wire are generally required to provide a higher level of protection. In the specific case of the helicopter pad lighting, the NEC restrictions on UF cable are particularly relevant. Helicopter pads are typically located in areas with significant activity, including aircraft operations, vehicle traffic, and personnel movement. These activities increase the risk of the cable being damaged, which could create a safety hazard. Additionally, helicopter pads are often exposed to harsh weather conditions such as rain, snow, and ice. These conditions can further degrade the cable and increase the risk of failure. By requiring conduit and wire for the helicopter pad lighting, the NEC helps to ensure the safety of personnel and equipment in the vicinity. The conduit provides a physical barrier to protect the conductors from damage, while the wire is selected to withstand the environmental conditions. In addition to the NEC requirements, local building codes and regulations may also impose restrictions on the use of UF cable. It is important to consult with the local authorities to determine the specific requirements for your project. When installing electrical wiring, it is always best to err on the side of caution and follow the most stringent safety standards. Using conduit and wire, even if not explicitly required by the NEC or local codes, can provide an extra layer of protection and peace of mind. In summary, the NEC restricts the use of direct burial UF cable in commercial and industrial settings due to concerns about physical damage and safety. Conduit and wire are generally required to provide a higher level of protection for electrical conductors, particularly in areas with significant activity or harsh environmental conditions. In the case of helicopter pad lighting, the NEC restrictions are particularly relevant due to the increased risk of damage and exposure to the elements. To ensure compliance with the NEC and local codes, consult with a qualified electrician or electrical inspector. They can help you determine the appropriate wiring methods for your project and ensure that your electrical system is safe and reliable. It is also important to note that the NEC is a living document that is updated regularly. It is essential to stay informed about the latest changes and revisions to the code to ensure that your electrical installations are up to date and compliant. There are numerous resources available to help you stay informed about the NEC, including online forums, trade publications, and continuing education courses. By staying informed and following the NEC guidelines, you can help to ensure the safety of yourself, your employees, and the public. In the context of this discussion, it's important to differentiate between different types of wiring methods. UF cable is designed for direct burial and is moisture resistant, but it lacks the physical protection offered by conduit. Conduit, on the other hand, is a raceway that houses and protects individual wires. The wires used inside conduit are typically types like THHN or THWN, which are heat resistant and moisture resistant respectively, but not suitable for direct burial without the conduit. The combination of conduit and appropriately rated wires provides a robust system that is less susceptible to damage from impacts, moisture, and other environmental factors. This is particularly important in commercial settings where there is a higher risk of physical damage. The NEC also addresses the depth at which direct burial cables must be installed. The specific depth requirements vary depending on the voltage of the circuit and the type of location. In general, direct burial cables must be buried deep enough to protect them from damage from digging, traffic, and other activities. The depth requirements are typically specified in tables in the NEC. In addition to the depth requirements, the NEC also specifies the type of backfill that can be used around direct burial cables. Sharp rocks or other materials that could damage the cable must not be used. The backfill should be free of sharp objects and should be compacted to provide support for the cable. The NEC also addresses the issue of ground movement. In areas where ground movement is likely, such as in earthquake-prone areas, the NEC requires that direct burial cables be installed with expansion joints or other means of accommodating the movement. This helps to prevent the cable from being damaged by the ground movement. Another important consideration is the potential for corrosion. Direct burial cables can be subject to corrosion from soil moisture and chemicals. The NEC requires that direct burial cables be protected from corrosion by using a corrosion-resistant cable or by installing the cable in a corrosion-resistant conduit. In addition to the NEC requirements, local building codes and regulations may also impose restrictions on the use of direct burial cables. It is important to consult with the local authorities to determine the specific requirements for your project. It is important to understand the purpose of the various requirements in the NEC. The NEC is not simply a set of arbitrary rules. It is a set of standards that are designed to protect people and property from electrical hazards. The requirements in the NEC are based on years of experience and research. By following the requirements in the NEC, you can help to ensure that your electrical installations are safe and reliable. When working with electricity, it is always important to be cautious and to follow all safety precautions. Electricity can be dangerous, and it is important to take steps to protect yourself from electrical shock and other hazards. It is always best to consult with a qualified electrician if you have any questions about electrical safety. In conclusion, the decision to require conduit and wire for the helicopter pad lighting is in line with the National Electrical Code's emphasis on safety and protection, especially in commercial environments where the risk of physical damage and environmental exposure is heightened.